Thank you very much. Yes, I'm not the youngest in the room today. So a bit of Taipy thing here. So Taipy comes from a snake, another snake called Taipan, which is an Aussie snake, Australian snake, which is very fast. So we mixed it with Python. That's the story behind it. So yeah, we did work for about 30 years in the building large AI application for large industry when we were in a company called iLog and later on as part of IBM. And the story is that we decided a few years back to stop developing in Java and C++ and really to move into Python. So that's how Taipy started. We noticed, so the initial thinking when we decided to build Taipy, by the way, Taipy is a Python package. In fact, it contains two different packages that have nothing to do with each other, Taipy GUI and Taipy Core. We wanted to build a package that was, able to do simple data presentation all the way to more complex algorithms, and not only machine learning. You've got a lot of other algorithms that exist here that you can use it for. But we basically felt, and a lot of the application we were building in those days and still till now are actually for end users. So of course there's a data scientist, or there's somebody that builds the algorithm, the pipeline, the algorithm, the code. But behind it, and most of the application we were looking at were for end users. Okay, and there's a very good talk I would like you to go to if you have time to listen to a TED talk by Andrew Ng, who presented basically this thing. It's not only about automated AI. You've got all these big guys that build all this automated AI stuff. On the other end of the spectrum, you've got the little grocer who's trying to predict something. It's very customized, doesn't have a lot of money, and you have a whole range of business in between. This is really where we were doing business in the past. So, one thing we noticed also is that a lot of the pilots developed in Python stay pilot. They were not able to move to the next stage. That's a number that in fact comes from Gartner, but that's also something that we wanted to change in the companies that were either into Python or going into Python. And the reasons for this is, there are many reasons for this situation. A lot of it has to do with lack of resources in the IT world for recruitment, difficulty also you need specialists. For instance, you build an algorithm, then you need a graphical guy, JavaScript guy, a DevOps guy, a data engineer, data scientist, data, and so on. So you end up basically with this, an initial pilot that this company built for 10K, fairly cheap. Then the full app was cost them basically 600K to develop. So they cannot do a lot of projects based on this. So in this case, they did an RFP. So this is one of the largest retailer in France called Intermarché. So they did an RFP for a cash flow prediction application for the CFO and the treasurers. These were the end users here. It cost them that. So they basically hired a company to do the job, 4 people for 8 months. At the same time, in parallel, they used Taipy. They did the same thing, and the customer could choose between which version he preferred. He preferred this one, and that's the software that is currently working. And it was done for about 60K with 1.5 people. Okay, so that means that this company, which is not a small company, the IT is about 2,000 people, can now do, because they have standardized on Taipy, they can do 10 to 15 projects, whereas before they had one successful project with 20, 30 pilots a year. So that's a bit the background behind it. So when we look at Python, we decided let's do all this application in Python. We noticed two big holes in the Python ecosystem. One was the GUI, the other one was the core, the execution side. So on the GUI side, I tried to map, and it's not all in there. It's a very rich, like a lot of the Python package world, it's very rich. And there's always a new package coming up. So on one side, you've got really powerful software. Fortunately, they require specialists, people who do basically know about graphical development. They either know JavaScript or they don't mind creating, you know, in a project. They are responsible for the graphical side. And you've got a lot of different products, so Plotly, Plotly.js, Plotly-Dash, you've got tkinter and some other backgrounds. That's not what we wanted to do, okay? Even though they are very powerful, you can build really nice application with this, but that's too much energy, and we're looking at, you know, doing something in low code for this. On the other side, you've got widget libraries. Some of them are more sophisticated than others. They do a bit more. We studied also, and we used that product. Who has used Streamlit? Who has heard about Streamlit? Okay. We failed completely with Streamlit when it came to deploying the application. The event loop basically is a nightmare. You can't have, it's not a multi-user environment, doesn't work on Jupyter Notebook, it doesn't scale. There's a flickering effect if you start using it with a bit of data, and so on and so forth. So we were very heavy users of Streamlit, and we decided not to use it, and hence the creation of Taipy GUI here. On the back end, it was all about, you know, creating pipelines that could do more, could do several things. So first, the pipeline concept, building pipelines, executing pipelines, and I will show you how to do that with the concept of doing it simply. A short learning curve. Okay. Airflow is not a short learning curve. Okay. It's fairly complicated. We wanted also to have some of the features of you know, versioning that you can find in MLFlow, for instance. Why to have another package for all these things? Scenario management. That's typically something that our pipelines are scenario enabled. So you can play with different versions, different execution of your scenario by changing a parameter. We call this scenarios. So it's the same concept, if you want, that you have in machine learning. They call it experiment, except that here, when you have an end user, he doesn't know what an experiment is. He wants to change some of the parameters and run the algorithm again. So that's what we call scenarios. Caching, of course, in a simple way. If you try to do caching in a lot of these existing, it's very complicated. Here, it's extremely simple. Plus some other facilities that we provide here. So these are the two packages. Again, it's open source. You can do pip install Taipy, and you get these systems. So now what I'm going to do is show you a bit of code. Again, it's low code, so it will not be, shouldn't be scary for anybody here. So the first concept that we see here, in fact, I can start by just showing you this. Okay. So think of Taipy GUI as an extended markdown. Okay. So this is a markdown after you have imported, installed it, you use the GUI. It's just a markdown string here that you pass. I can remove the parameter here, it's not needed. And we're going to run this. Okay. So when I execute this, you basically it will spin off a web server, and you will see your markdown appear on that page here. Okay, so nothing. This is in italic, as mentioned in the markdown. I could refresh the server each time, but here I'm going to run it. So here, what you see is the first object, Taipy GUI object. So it's basically indicated with those less and greater signs, and everything else inside is divided or with pipelines, pipes. Sorry. The first is always a Python object, so it could be an integer, a dictionary, data frame, NumPy arrays, a lot of different types of objects. And the second field is always the type of graphics you want to show. So here it's a text, here it's a slider. And after that, it shows the different properties that you associate. And when it gets longer, you can put them in a dictionary so that it's lighter. Okay, so let's run this. Sorry, I'm going to stop this. Okay. You can notice also that the syntax is highlighted, so the kind of syntax checker that you have on Visual Code with also the code. How do you call this? It finds for you all the names automatically, so it saves you time when you do the coding. And you see the interaction. I didn't need to do anything. The two objects are directly connected. It's just to show you a little bit of the interaction that you can build, because that's usually the time where it's you can spend a lot of time. On the third example here, something a bit bigger where we not much. So one thing I've added here is a chart, which is a line chart, where I pass the data. And in this case, data is just a list, which is in fact the output of a sine curve here. Okay, the sine curve returns basically a list of points, and I'm going to display that as a line chart. So I could have directly not use this and call directly, instead of data, call the sine function and put it in there. And that's all what my program would have done. Or I can create a kind of callback here. If this variable that is changed is called decay, which is here, let's recompute the sine function. So basically, whenever you change the slider, recompute the sine function. So that's what you are going to see. Sorry, forgot to do that. So by the way, all of this works on notebooks. In fact, that's the only graphical tool that you can use to build, a bit more complex than just a widgets within a notebook. Okay, so here again, it's not to make anything fancy here. You just have the interaction that we're looking for here. You've got a whole range of objects. So the documentation, of course, is online. You've got all the different objects that exist. All the Plotly graphics are mapped, so they exist. You can bring your own graphics. There's an API also to bring your own graphics inside. And you've got the what we call the layout, if you want, to define how your pages look like when you build your graphics. You have some other demos. I will show you the demo maybe a little bit later. Again, my purpose here was to show you more the interaction, not to show you something pretty and nice. Now let's move to the next topic, which is Taipy Core. So currently you have two choices when you build a pipeline. Either you code it in Python or you use a graphical editor. And we do provide an extension of, so here you have your config, you have an extension here which shows you under your preferred IDE, so in this case Visual Code, an editor where you can create data nodes in blue, tasks in red. So of course these tasks are directly pointing to your Java code. That's inside the IDE. That's the principle here. Okay. So this is a pipeline. So again, you can create all this. This is another pipeline that also feeds into this one. So you can create that graphically and save it, and it's saved as a .toml file, okay, which is typically a read format for configuring. It's like YAML, if you want, for those who have not. It looks like something like this, for instance. Okay, that's a readable format that corresponds to your graph here. So when you are building a pipeline, like here, here I'm doing it in Python. So I have to do step by step. I create my first data node, which is a CSV type. There is a scoping concept to decide, whether this data node is available for all my pipelines, only certain pipelines, on the scenarios, and all these things. So it's a scoping concept, but you have all different types of readers and writers for SQL, NoSQL, Parquet, TensorFlow format. You have also a generic reader writer that you can create yourself to create your own data node. A data node may not only be data, it could be a parameter. If you look at, if I go back here, this is just an integer, which could be a parameter that you get from the interface, from the end user, for instance. Okay? And this is how we would create scenarios. For instance, the end user would modify the day from which you want to predict. So it's a prediction task here. And that would create another scenario automatically. So it's the same pipeline, but different version of the pipeline with different parameters. Okay, so the scenario is really inside the concept of pipeline. That's why we say our pipeline is scenario enabled. Okay, so yes, so let's go back to the code for this particular program. So here we created another all the data nodes that I have. Some of them are data output. I reached the pipeline and I say which tasks are going into the pipeline. It creates that automatically, the sequence and everything. You don't have to worry because of the... So instead of writing all this, the alternative is just to load the graphics, to load the configuration file that was saved previously from your graphics, from your pipeline. Okay, so your code will be only load the pipeline from the TOML file and execute what is needed. You can execute the whole pipeline, part of the pipeline, one task in the pipeline. That's your decision. Okay? So that's what the options that you have here. Either to code everything in Python or just create graphically your pipeline, load the pipeline that you have created through the graphics as a config file and execute what is needed. So here what will get executed is the whole pipeline and we are going to print the output, which is a set of predictions. It's a very simple prediction. It doesn't matter really what these tasks do. So what I'm going to do is just run this. Keep in mind that I did run this before. It was run just before I came here. I ran this particular thing, and you see here, sorry, let me run it twice so that I'm sure what I want to show you appears. You see the first one, so there are two jobs, there were two tasks. So when you execute a task, it creates a job. So you have this capability of, you know, the precedence, the parallelism that can occur. It's inbuilt inside Taipy Core. And the first one escaped because nothing has changed, so I don't need to run it. I see so many times data scientists, you know, writing the code, and depending where they are, they actually say, "Oh, I'm here." So they say, "I don't need to run this code," so they modify the code to say, "I just want to run it this way." If they were to use pipelines, it would be easier. The whole reason usually for pipelines is in fact there are two reasons. One is the caching mechanism, so that you can run the same thing and don't worry what to run, not to run. And the second thing, you can work with a team. You can share the pipeline and share the task between people. Okay, so that's one other thing. Let me look at the time. How much time do I have? Okay, good. So yeah, so of course the core works, of course, in notebooks or not notebooks. It's less of an issue here. One thing I would like to say, also coming back to the graphics, I forgot to mention, is the same here. There are capabilities for big data. For instance, in the graphics, we have special filters. If you try to load in a line chart 3 million points, your program will collapse. Any Python program will collapse. So what you want to do is actually do something a bit smarter. So we do provide filters, smart filters, for instance, on the line chart. You can say, use this filter, I want to see 2000 points only, and please remove all the points, but only the points that modify the least the shape of the curve. And that's extremely useful when you analyze, for instance, data from IoT or this kind of thing where you have a lot of points. So you have this capability for line charts, for scatter plots also, where you can use something smarter than just shading when you are really overwhelmed with the number of points. So there are capabilities inside Taipy GUI for big data. On Taipy Core, it's usually what people use these days more and more. People use tools like, or packages like Dask or Modin, and less and less people use Spark. That's what we noticed. But the software basically can read. We have basically data nodes that can be Parquet, but that can be also different formats from Dask or Modin. Any of you are using Dask or Modin, for instance? Okay. And anybody who is on Spark for big data? Ah, what have I said here? Yeah, so well, anyway, that's what the NVIDIA people told us. Yeah, we do a lot of work with NVIDIA. We are fairly complementary with what they do with their CUDA, different CUDA levels and so on. So we really do, and they introduce us also to their large customers where we build graphics and all this stuff with them. One thing that I want to note also is that we are a startup, but we have done things a bit the other way around. The fact that we are not as young as most of you guys also is sometimes has some advantages. We had very strong contacts with large companies. So the software has been built with McDonald's, with Intermarché, with Samsung, with ArcelorMittal. So very large companies that really gave us a lot of feedback and a mixed bag. For instance, there were some finance company that were in fact, a lot of the finance company are extremely sophisticated with the usage of Python. They know everything. It's quite incredible how much they use Python. Société Générale, we're talking about 200 to 300 users, for instance, of Python. JP Morgan, we talked to them 2 weeks ago in New York City. It's really incredible. And so these people are really into Python. And we have the other extreme, which are people who just get their feet wet with Python a little bit, or nothing, or they are thinking about it. Some of them because they have no choice, or they feel that way, and they look at Taipy as an easier way to get into these kind of applications. Okay, so do I have time for a demo? 7 minutes? Yes, I do. So we are open source. You can get everything you need on the website, documentation, demos, tutorials, and so on. At the risk of looking a bit too salesy to you guys, I have to tell you that the pipeline editor is in beta at the moment. It's going to be released in January, okay, towards the second half of January, okay. So on the website, which you have here, so you have the documentation online, you've got the getting started and everything, and you have demos. And I will show you a demo which is not particularly sexy. I mean, there's nothing fancy about this one. What's really sexy, it was developed in a couple of days by somebody who knew nothing about Taipy. Zero. Okay, brand new student, data scientist, not a graphic guy, somebody who basically is at ease with Python and no experience. So I'm going to choose this demo, which is also a little bit different than the standard machine learning stuff. But it shows all the concepts that exist. So I will call this Eindhoven. Okay, so what you see here is a very simple problem, which is about production planning. So it will be a bit of a change from, again, from the forecasting, classification, anything. It's a factory that has two products. I think it's a wooden, they make wooden chairs and tables. These two products, this is the demand over the next 11 months, okay, for the two products. So each month there is a particular demand, and they need to come up with a production plan to meet that demand. So you've got the graphics that has been built. You've got, you know, different tables that correspond to the initial stock during the current month, the initial production level for the current month, and the demand, not in the curve that you saw, but as a table here. So what I'm going to do is to create first a scenario here. So when I create a scenario, because the model is quite simple, there are only two products, it's going to read the data that is needed, load the data, so it runs the whole pipeline, and here call the algorithm. The algorithm is an optimization model, it's mathematical optimization, and it finds the optimal solution to meet two objectives. One is to minimize backorder cost. Basically, you cannot meet the demand on time, so you are late. So try to minimize that. And the opposite, which is you purchase too much raw product for the demand that you have. So these are kind of two objectives that are opposite. And it has computed the result. You can see that it's doing something not too stupid. If you look, for instance, at this graphics, which is the final product, which is, I think, the chair here, or the table. So you see two curves here. The blue curve is actually the production of that particular product, the product, finished product A, which is the chair. You can see that it respects the maximum capacity, that it's a constraint. You cannot produce more than that every month. But it was smart enough to overproduce compared with the demand. So here it creates stock because it knows the demand is going to be higher here. So it's smart, it's doing the right stuff. And I've created a scenario with all the results, the value of these two objectives. And now I want to do this play around thing that the end user like to do, which is to change something. So let's go back to the table, and I'm going to change the capacity, for instance. Okay, make it a bit smaller. I could re-optimize the current scenario, but I'm going to create a different scenario now. So the same pipeline, I change some parameters, and I run, and I have a slightly different value. Of course, the next thing I want to do after creating a few scenarios, and by the way, you notice, yeah, I will do that later. You can select, so here scenario 2, scenario 1, and you can compare the two according to the two objectives. So one is better than the other, and you can compare that for a scenario to scenario or over time. So when you code that in Python, it's extremely simple because we have the concept of scenario, we have the concept of cycles here. So it makes your life kind of easy as a developer. Here I want to look at what happened because I've run that over several months. So you can see the KPI over time, and for this I will extract from each cycle. The cycle here is a monthly cycle. I will extract what we call the primary scenario. You can see that's the scenario. In fact, that two scenario. That's this one. This is the one with the flag, which is So you don't need to use scenario, by the way. If you don't want to use scenario, you are free not to use them. But here we are saying that for that month, that's the scenario that's going to be published. That's the official one, and you can change it, of course. So all this way of working, which is really what happens very often. For instance, in McDonald's, every week they need to project forecast. Sometimes it's every month or every hour. It depends on the situation. All of this is also available within the Taipy Core system. Okay. So that shows you what the kind of application that can be built. And again, that was developed in 2 days. Okay. So that's, again, I don't want you to necessarily understand what's behind it, or to say it's not so nice, or it's just the time it takes to do the development without having specialists for everything. Okay, so that's you've got some other charts that you can see and save and so on. Sorry, it's here. No, there used to be a pie. No, it doesn't work. Okay, so so how are we doing here? 5 seconds. Who said I wasn't good? Okay, perfect. Question time.
I have a question.
You want the microphone or?
I think I'm loud enough.
Yep, I think that's fine.
You mentioned at the beginning that you had a lot of issues with deploying Streamlit.
Yeah.
And you failed. What will be the difference in deploying Taipy comparing with Streamlit? Because if I got correctly, it's Flask application, yes? On the background.
Yeah. Yes.
So what will be the difference then?
It's not only the deployment file, it's the capabilities that you have. So first of all, I told you it's single user. So here I can launch for you, for instance, 2 different runs of the same URL. It's the same application, two different users. If I modify, if I do something on one, it will not be reflected on the other one. If you do that with Streamlit, it's the same thing. So if you have 2 users, you have to duplicate completely the execution of the thing. But the most difficult thing in Streamlit is the event loop, which is how the product has been built. So if you have some input data or something, the data will not be persistent, so it will erase the data. Of course, you have some caching mechanism, but it becomes a nightmare, and with side effects like flickering. The third issue is scaling. Not even with big data. If you start having a few pages with a bit of data, say 10,000 lines and a bit of event, it starts to, and if you have something even bigger, then that's the end of it. And it doesn't work also on Jupyter notebooks, and so on and so forth. So that's I mean, it was a great product at the start. I was the second user, and I know the CEO. He's the son of one of my very good friends. But you know, when he was like, I talked to him at some stage and tell him, you know, you have to do something. You are hitting here the ceiling. I can't use your product. I was a user at that time. I was dealing with applications with end users. I said, there's no way I'm going to use unless you modify. And he refused. And he was already in talk with Snowflake, so that was too late. So that's the story behind it. But we absolutely tried very hard to use Streamlit. But it's very hard to change. That's the way the internals do work. There are a lot of things on Taipy also that are optimized for the event management. So for instance, we have customers, you will never be able to do that. Anyway, it's a notebook issue, but you could have a platform like, I don't know, for those who are using Databricks, for instance. You can have Databricks running some graphics, redirect that with ngrok on your local screen, and it's great. You can do this kind of thing with Taipy. So, sure.
Does this support spatial data, so visualizing spatial data frames and building scenarios on top of that?
So you're talking about something like GIS kind of thing, or?
Yes.
Yeah. So at the moment we are very much. The product is new. It's 6 months old. We are built on top of Plotly. So all the Plotly thing that you can do. So there are some mapping capabilities. So most of the Plotly object will be mapped in January. Now we have about 50% of them mapped. We have an API also to bring external graphics into the software. Okay, and we are also listening to our customers. So some of them are extremely specific. For instance, some of them want not a read-only Gantt charts, but a fairly complex Gantt charts with interaction and this kind of thing. For those who have worked with Gantt charts, know what I'm talking about. These are very complex things to do. We are building that also with some of the customers. So if you have something extremely specific about some of the graphics that you would like to see, you can either use our existing API, JavaScript API, or we may get, if we see that there is a potential for more users, we are happy to work on it as well. But mapping, we have a lot of customers using it for mapping, more in the supply chain context, you know, with typical stuff. You know, you've got the map, you've got a layer of warehouses, factories, links, different thicknesses. But it's more or less Plotly at this stage, which is, you know, fairly large in scope. But again, you can bring additional GUI widgets from your liking.
So regarding pipeline execution,
yes.
You're relying on the resources of a client machine, or are you deploying the solution on a server?
Both are possible. You can obviously, what I showed you here was running locally, but you can run that on a server in your company. Or
okay, and then when you deploy on a server, do you have a notion of like multi-tenancy, or is every user deploying his or her own, let's say, tenant of the product?
So we are this capability of multi-tenant capabilities is something that we don't know at the moment, but we are working with a company that is special. It's going to be built on top on existing software that does that very well. So we are not yet into that level.
In order to use the GUI, do we really have to write the pipelines this way, or can the
No. These are completely different packages. You can use the graphics without. You mean the pipeline?
Yeah.
The pipeline graphics, right?
No, so if I say build my pipeline through Kedro or in some other manner,
Yes.
can I still use GUI?
Oh yeah, absolutely. The graphics is independent from the Taipy Core. Absolutely. There's no. As I said, it's two independent packages, and it will remain that way.
Last question.
Sure.
Thank you for your talk. You made a comparison of some of the tools compared to Taipy. Did you also look at Gradio? I see.
Yeah.
Gradio also
So
moving forward by Hugging Face.
Sure. So Gradio is very much machine learning oriented. We are much wider than that. No, it's a good tool, but we never compete with Gradio. Again, we look at applications that you want to build. Gradio has there could be some overlap, but it's really for machine learning, and it's usually even more low code than we are. It's straightforward, yeah, and it's very close to almost like a Hugging Face kind of thing. But yeah, we have a wider scope than Gradio. Thank you.